This is chapter 5, problem number 9. What is the maximum speed with which a 1,200 kilogram car can run a turn of radius is 90 meters on a flat road if the coefficient of friction between tires and the road is 0.65? Okay. All right. So let's pay attention on a few things. Okay. You see this one is called coefficient of friction. From the last problem, what we learned is, we learned a few things. First of all, centripetal acceleration is equal to velocity squared divided by r. That's one formula. The other one is the force that need to move an object with friction, okay, or the frictional force that is equal to coefficient of friction multiplied by the normal force. Okay, so this is a new formula. All right. And what is the unit of coefficient of friction? Is unitless. There's no unit for it. Okay. All right. So what we are looking for is we are looking for velocity. Okay. So let's see what the story is. So a car is running in a circle. We are looking at the side view. Running around like this. The radius is 90 meters. Okay. If this is ice, okay, if there's no friction on this road, can a car go in a circle? No. If the car go a little bit straight, it cannot make a turn and it will continue go on. Okay, so there must be some friction holding it so it can go round and round, and that friction will be equal to the centripetal force. Okay, so from here, so the centripetal force should be equal to the frictional force. What is centripetal force equal to? Force is equal to m times a. So centripetal force will be equal to m times a. A is over here. So m times v squared divided by r. And by the way, the lucky number for this problem is 3. I like the number 3. So 3 is your lucky number. All right. Centripetal force that is equal to friction. Friction is over here, is equal to coefficient of friction times the normal force. Normal force in this case is equal to free body diagram, mg down. That means the normal force is mg going up. So normal force will be mg. Okay. What are we looking for is we try to solve maximum speed. All right. So how do we calculate for velocity? The m can cancel out both sides. Velocity v is equal to, well, v squared is equal to coefficient of friction times g times r. Okay, and therefore velocity will be equal to square root of it times r. Okay, and by the way, when you look at this, does it depend on the mass of the car? No, the velocity doesn't depend on the mass because the mass cancel out. That means even if you have a bigger car or smaller car, it doesn't matter. The maximum velocity is about the same. All right, so I'm going to plug in everything here. So that's equal to square root of, coefficient is given 0.65, g is 9.8, and r radius is 90 meters. This number over here, the mass of the car, it doesn't matter. No matter what the mass is, still the maximum velocity is the same. Okay. All right, so let's calculate it. It is 0.65 times 9.8 times 90, and take the square root of it. Square root of second answer. Okay, what I get is about 24 meters per second. That is your maximum velocity. Once again, the lucky number for this problem is number 3.